Hi everyone, in this Colab notebook, I'm going to show us how to create vectors and matrices using the Python NumPy and PyTorch library. And I'm also going to introduce us to the transpose operator with the capital T right here. This is because transpose operator, we're going to use that operation often in machine learning and deep learning. Now, to create a vector in Python, you can use the array method in the NumPy. One thing you're going to want to do is to create a vector using double brackets instead of single bracket. Either one would work, but the single bracket is going to give us one dimension, and the double brackets right here is going to give us a 2 dimension. So, like, for example, right here, right, we're creating a vector. Row vector of 1 row and 4 columns right here. And if you do this right here, and you do the transpose, apply the transpose operator operation on the vector, it's going to give us the correct transformation to a column vector of 1 column and 4 rows right here. If you're going to do using this 1D, this single bracket right here, it's just going to repeat the one-dimensional vector, and it's not going to give us the column. So use the double bracket to create a vector, and then you can apply the transpose operation on that vector with a capital T right here, and it's going to give us this result right here. So the transpose is basically just switching the row and column. For example, if you look at this 9.8 right here, right, the position of this is the first row and third columns. So if we do the transpose, then the element would change to third row and first column. See 9.8 right here, become third row, 1, 2, 3, and first column. Now, if you can apply the transpose twice, double transpose, it's going to give us back the original vector or matrix. For example. Now you can see the shape of the vector and the transpose vector right here by doing this dot shape right here. The original vector is 1 row by 4 column, and the transpose is 4 rows and 1 column right here. And the type of both of these are ND array. This right here is another way to create a vector using the array, NumPy library. You can see right here, right? If you print out the vector, the transpose vector, and the double transpose vector, it gives us essentially the same result as the original procedure right here. And you can also see the shape, both the vector, the transpose vector, and the type are similar to the previous process. You can create a matrix using the NumPy library. For example, right here, I'm creating 2 by 4 matrix. See right here, when you print it out, it's going to give us this right here, this form right here. And you can apply the transpose with a capital T again to the matrix, which would transform it to a 4 by 2 a matrix right here. Again, right, so for example, if the number 11 right here is first row, third column. Now, when you transpose it, it's going to switch around. It becomes third row and first column right here. The order of the number is going to be the same, right? Just the position, the orientation is switching. Now, you can check the shape and the type of the matrix by doing dot shape and the type right here. So the shape is originally 2 by 4, it becomes 4 by 2. And both of the matrix and the transposer matrix have the type of ND array. Now, you don't have to use the NumPy array to create vector and matrices. You can also use a PyTorch library, a tensor method in the PyTorch library. So for example, right here, right, I create a vector, a row vector, using the tensor in the PyTorch library. And I can print out a vector right here, right? And once I had a vector, I can do the same capital T operation, dot T right here, or the double transpose. The dot T would transform the vector into a column vector, and then the double transpose would bring back the original vector. And you can also check the shape and type of the vector right here, which is 1 by 4 originally, now becomes 4 by 1. And both of these have a type of tensor. Okay. Finally, you can also create matrix using the PyTorch library. And looking at this right here, we are creating a 2 by 4 matrix again, right? So when we have this 2 by 4 matrix, we can do that dot T to transpose it to a 4 by 2 matrix, and then the double transpose would bring back the original matrix again. And you can see right here the shape of the matrices and the type, which is tensor type in the situation right here. Finally, if you want to create a column vector, then you can do it like this right here. Okay, so you can see if you print out a vector, it's going to have a column vector and the shape is 4 by 1. And then if you transpose it right there, it's going to become a row vector and the shape is going to be 1 by 4. I hope this helped right here. And thank you, and you guys have a good day.